This video is to review inverse functions. The first thing I'm going to talk about is graphically how we represent inverse functions. And so it's important to note that graphs of inverses are reflected over the line y equals x. So I've given you the line y equals x. We should know that it's this line that comes diagonally up through the origin, and that's where that is. So the example question we're going to do down here, which of the following graphs shows the inverse of the g of x equals 2 to the x? So this is one of our parent functions that we should know. It's the exponential graph. So we want to find out which of these is the inverse. So I'm going to look at these and say, okay, where is the line y equals x on each of these? So just kind of draw those in so I can picture kind of what's going on here. And then I also want to think about what does the original graph of this look like. And if I just quickly sketch that over here, I know my exponential function, my original parent graph, looks kind of like that, if that's a rough sketch. So I know that if I reflected that across the line y equals x, it would be flipped over down across that line. So which of these looks like it's been reflected down across that line? And that is answer choice A right here. Okay, the original function would be up here, and it's been reflected down across that line. Okay, if you look, this right here is actually close. That's closest to what the original function was, but they want you to pick the inverse. The next two examples that we're going to look at is actually algebraically figuring out what the inverse function is. So remember that this is f of x is really y. And to figure out what the inverse is, we make y be x and we make x be y. And then we're just doing inverse order of operations to solve for y to get y by itself. So we're adding 1 to both sides. So we get x plus 1 is equal to 2y cubed. Then we don't want to deal with this exponent first. We want to do that last. So we're going to divide by 2, divide by 2. And I'm going to go up over here so I have some more space. So x plus 1 over 2 is equal to y cubed, and then I would take the cube root of both sides. So I would have the cube root of x plus 1 over 2 is equal to y. That would be my inverse function, and remember that it would probably have that inverse notation of this is equal to the cube root of x plus 1 over 2. Alright, I'll do one more example real quickly if you wanted to try this next example on your own before I went through it to see if you understood how to do this and then check your answer. You could pause the video here. So you're going to make this be x and this be y. Okay, the first thing we're going to do is add 3 to both sides. So we have x plus 3 is equal to y plus 2 squared. Now is where we want to square both sides. Excuse me, we wouldn't want to square both sides. We would want to take the square root of both sides. So we'd have the square root of x plus 3 is equal to y plus 2. And then lastly, we'd want to subtract 2 from both sides. So the square root of x plus 3 minus 2 is equal to y. Now, a common mistake here is subtracting 2 inside. Remember, we can't do that. That has to stay on the outside. So your final answer here would be the square root of x plus 3, that's on the inside of our radical, minus 2. If you have more questions about inverse functions, please see your math teacher.